As we get closer to hurricane season in the Caribbean, here is some critical information on the impact of storms on the health of Caribbean children.
Since the late 1800s, scientists have tracked sea surface temperatures across the globe. But something changed in the late 1980s. Temperatures began rising and staying above average. This warming trend is widely linked to climate change. And it's not just about the ocean. Warmer seas fuel more frequent and more intense tropical storms. In the tropical Atlantic, severe weather events surged around 1990, especially those impacting the Americas. Here's where it gets personal. That shift in weather patterns coincides with a sharp rise in dengue fever outbreaks. A clear signal that climate and disease are deeply connected. At the time dengue fever cases began to increase in the early 1990s, I was tracking something else. A rise in type 1 diabetes cases among children ages 19 and younger in the U.S. Virgin Islands. What caught my attention was the timing. Spikes in the incidence of childhood type 1 diabetes often followed within a year of dengue fever outbreaks. That pattern led me to a question. Could dengue fever infection be triggering type 1 diabetes in children? This was a possibility since research studies have shown that some viral infections can trigger type 1 diabetes. Another possibility was that both dengue fever and childhood type 1 diabetes were responding to the same weather patterns. The idea had biological plausibility. For example, in cooler climates, childhood type 1 diabetes cases tend to increase in the winter months when children spend more time indoors and are exposed to viral illnesses. In the tropics, weather conditions influenced by climate change might be having a similar effect. This was the hypothesis, and it was time to test it. To test the hypothesis, I turned to the data. We gathered 25 years of climate records on rainfall and temperature from 1980 to 2005 in the U.S. Virgin Islands. We matched these data with annual incidence rates of type 1 diabetes in children aged 0 to 19. Then we applied advanced statistical modeling techniques to look for patterns, ways the weather might be shaping disease. The goal was simple, to see if climate shifts could help explain the surges we were seeing in childhood type 1 diabetes. Using second-order response surface polynomial modeling, we found a striking pattern. The epidemic-like surges in childhood type 1 diabetes incidence over the years were not random. They aligned with climate shifts, high rainfall and low temperatures. The highest childhood type 1 diabetes incidence rates in the U.S. Virgin Islands occur when rainfall is highest from normal and temperature is lowest from normal, with the rainfall being the more significant factor. Climate wasn't just background, it was a trigger. This study reshapes how we think about chronic disease in tropical regions. Climate change isn't just about heat, it's about health. And in the Caribbean, children may be the first to feel it. Let's bring this data to light. Let's protect our communities. Because when the rain falls harder, we need to look deeper.
On most